The urinary system is vital to our everyday life, even if we don't realize it. Nearly 180 liters of water is created a day, but almost all of that water does not leave the body. It is reabsorbed. Only a small amount is excreted as urine.
Filtration is the first step of urine formation. Blood flows to the kidneys carrying waste products to be removed. It courses through the glomeruli of nephrons, and a lot of the fluids, such as chemicals and dissolved waste products, soak through the membrane of the glomerulus, and there it flows into the Bowman's capsule. The Bowman's capsule is part of the glomerular filtration process. Chemicals in the blood, such as waste products, blood, salt, and glucose filtered out of the blood is referred to as glomerular filtrate. It also contains a waste product called urea, which is also created by the liver to help eliminate ammonia products created by the breakdown of amino acids. Urea is the most abundant waste product excreted.
The next step is reabsorption, which is where the substances travel from the Bowman's capsule to the proximal convoluted tubule in the loop of Henle. Water, glucose, and other nutrients like sodium are reabsorbed back into the blood. Large amounts of water are reabsorbed by the PCTs because the force of these tubules actually push out the water, which is a passive transport. Water is also diffused passively through the descending limb of the loop of Henle because it is more permeable to water. Also, glucose is entirely reabsorbed back into the bloodstream via active transport because it is so important to the body. However, sometimes nephrons can only absorb so much sugar and some of it is released through the urine, which is not good and can be a sign of diabetes.
Sodium is also actively reabsorbed back into the bloodstream because as it travels through the ascending limb of loop of Henle, which is more permeable to sodium, energy is needed to move the solutes up. As one's salt intake increases, the rate of absorption decreases, so more sodium is excreted into the urine.
Finally, the last process is secretion. Ultimately, secretion is reabsorption in reverse. Substances from the blood and the capillaries move into the distal convoluted tubules and collecting tubules. Hydrogen, potassium, ammonia, or urea, and certain drugs are secreted. As these substances enter the tubules, they mix with water and the other wastes to form urine. These flow through the collecting ducts and into the ureter to finally leave the body as urine.
To relate to Bill's issue, he spent the whole day drinking alcohol instead of water and being active on a 100-degree day. He felt nauseous and dizzy the next day because his body was dehydrated. His body was struggling to maintain a normal water balance.
Alcohol inhibits the secretion of ADH, meaning low ADH levels mean the nephrons are absorbing less water, resulting in increased urine production. ADH is negative feedback because the body is not experiencing a normal status, so the body will work to return to homeostasis. ADH is then released to maintain a normal water balance, so it is negative. When water balance isn't maintained, the body goes through steps to bring it back to normal. When water balance is low and you're dehydrated, the neurons in your body receive that information and stimulate the osmoreceptors in the hypothalamus.
Once these osmoreceptors are stimulated, the hypothalamus creates the feeling of thirst and sends signals to the pituitary gland to secrete ADH to the kidneys.
When ADH is secreted and goes to the kidneys, it triggers an increase of permeability by increasing the number of aquaporin channels in the nephron, so more water will be reabsorbed back into the blood.
Once more water is reabsorbed, ADH levels fall and urine output is low but concentrated because there isn't much water to dilute it.
But when water balance is high and you're overhydrated, osmoreceptors are stimulated and tell the hypothalamus that there is a low solute concentration, and the hypothalamus tells the pituitary gland to secrete less ADH.
When the ADH levels fall, the collecting ducts are impermeable to urine and more water is excreted rather than reabsorbed.
When more water is excreted, more urine is released from the kidney and is diluted.
So, what's the difference between ADH and aldosterone?
ADH is released when water balance in the body is low. It is released to the kidney from the pituitary gland and makes the nephron absorb more water.
Aldosterone is released from the adrenal glands on top of each kidney. The adrenal glands secrete aldosterone when decreased blood pressure is detected. The chemical will increase sodium reabsorption in the nephron and will increase the osmolarity of the fluid that is outside of the nephron, and in result will lower the blood pressure.
They do both result in more reabsorption of water and increased blood volume and pressure. They are also both secreted into the blood to reach the kidneys. When aldosterone signals more reabsorption of sodium, it helps water be reabsorbed too. Ultimately, water cannot be reabsorbed without the presence of sodium.
So, how did the events of Bill's day impact the body's ability to conserve and balance water? His level of activity and high intake of alcohol affected his ADH levels. His ADH levels were low because of his alcohol intake, and that increased urine production, which means more water was being excreted when it needed to be reabsorbed because he was being active.
How could Bill have prevented his horrible hangover? Bill could have drank more water between his drinks of alcohol because then his body would not have been so dehydrated and he would not have felt the dizziness or nausea he felt in the morning because his body had to conserve so much water.
What effect did sweating have on Bill's water balance? Sweat accounts for a large percent of the water your body loses, and since Bill was not staying properly hydrated when he was playing football and chasing kids around in 100-degree weather, he was sweating out a lot of water. ADH couldn't trigger the nephrons to absorb, and that's why Bill felt a terrible hangover when he woke up.
What happens when water balance isn't maintained? When water is not available to dilute the body fluids and waste products in the nephron, osmolarity will occur, and when fluctuating levels of osmolarity happen, such as different levels of aldosterone, cells will swell or shrivel depending on the hypertonic or hypertonic solution, and that can permanently damage the cells. So water is needed to help maintain an isotonic solution to prevent damage to the cells.
Would blood ADH levels be higher or lower than a normal in a person who just completed a 3-mile run without drinking any water? High ADH levels because the body is straining itself and using up the available water through sweat, so ADH needs all the water it can get to be reabsorbed back into the bloodstream.
How can drinking too much water throw off electrolyte balance? The body needs a certain amount of sodium and calcium in the bloodstream to maintain proper orientation and operation of the brain and muscles. If you have electrolyte imbalance and consume too much water, sodium levels will be too low, which causes cells to swell. Decreased sodium intake and excess water can affect the nervous system, muscle spasms, twitching, and convulsions. The body's nerve reactions and muscle function are dependent upon electrolytes.
How do you think the diuretics affect the kidney, the fluid, and electrolyte balance in the body and overall blood pressure? Diuretics increase the rate of urine output because it inhibits the amount of sodium and water in the body to be reabsorbed. The more they inhibit the reabsorption of water and sodium, the more urine will be produced, and lack of sodium reabsorbed will lower blood pressure.